Now, in this next example, you realize that it is actually not that trivial in the sense that you realize that it's not in the straight line form of equation. Why do I say that? Because you realize that in both variables, in both variables on the right hand side, there is actually an x in both, which means that we need to try and convert the equation into a straight line form. And how do I do that? Notice how I always like to place my y-intercept at the right hand side, okay, and how I like to place my big Y alone on the left hand side. So that's what we're going to do. It's the same thing here. Okay, one of the things you can do is actually to divide both sides by x. The left hand side by x, right hand side by x. So you get y over x equals to ax plus b. I hope that for now it is actually quite obvious for you to see what the big Y, big X, M and C is. Okay, big Y is y over x, bx is just small x, m is the gradient a, and c is b. How do I know that I should stop here? Okay, you stop here by checking once again. Is your y in terms of y and x only? Yes, it is. Is your x in terms of y and or x? It is. Does your gradient contain any x or y? No, it doesn't. It's only in terms of the constant itself, and c is just b on its own without y or x. So that's where you know you stop. Okay, let's take a look at more examples. Let's take a look at part D. Y equals to a square root x plus b square root x. Okay, now same thing, you realize that both also contains x. So how? Okay, what you can do is to one of the things you can do to remove the denominator is actually just to multiply everything by square root x. Okay, so y times square root x will just give you y square root x. A square root x times square root x, okay, is just a times x, because square root x times square root x will just give me x, and then I'll just get plus b. So for now, you can already see that it's very easy. This is your y, this is your m, this is your big X, this is plus c. Okay, so y equals to y square root x. Big X is equals to small x, m is equals to a, c is equals to b. Now, is there another alternative to this solution? Okay, I want you to think about it. There's actually another alternative. Okay, and the other alternative is actually to divide both sides by square root x. So y over square root x will just give me y over square root x. A square root x divided by square root x will just give me a. This is the tricky part. B over square root x divided by square root x, you realize it's just times 1 over square root x. So that will give me b over x. Okay, so rearranging this, I will get y over root x plus b over x plus a. Y over root x equals, I want to factorize out the b, so that it's very obvious what my big X is, plus a. So y is equals to y over square root x. Big X is just 1 over small x, m is b, and c is a. Now notice how I always like to write my big Y as a fraction like that. Now in exams, please do not do that. Please write it in the fractional form. I'm just writing it this way because there's no space on my PowerPoint slides. Okay, now let's take a look at part E. Okay, for part E, you realize that now you have something that is stuck on the power of x, which actually makes this not a very simple example. Okay, you realize that in order to bring the n down, you need to log both sides. Okay, so I'll get log y equals to log ax to the power of negative n. Now I can split this up because there is a multiply in the middle. So I'll get log a plus log x to the power of negative n, bring down the negative n. Okay, now you realize that your y-intercept, your constant, is not at the outermost right hand side. So rearrange this, and it's very clear that here big Y is actually just log of small y, big X is log of small x, m is equals to negative n, and c is equals to log a. Okay, now for this the second last example, you realize that your x is stuck in the power here. So how? Okay, you want to be able to log this. So how can you do that? Okay, what you can do is to shift x cubed to the other side, log both sides. Please don't go and expand this. Okay, the only time you can expand this out and bring the log in is when it's a divide or multiplication. Okay, please go and revise on your logarithm laws. Okay, then from here, you are able to bring x minus h down as the power. Expand this will give you x log a minus h log a. rearrange it a little, and you will get log A times x minus h log A. Please don't forget the brackets. Okay, so from here it's really very obvious that this is the big Y, this is the gradient, this is big X, and this is C. Okay, how do I know when to stop? Okay, check. This is in terms of X and Y only. This is in terms of X or Y only. M is equals to log A, which is in terms of the constants only. C, you get negative H log A, which is also in terms of the constant. So that's where you know you have to stop. Okay? Okay, last example. Okay, before I go through this example, I want you to try this for yourself. Okay, take a look at the example. From here, how would you extract out big Y, big X, M, and C? Okay, I think the first instinctive step for all of you to do is actually to multiply X plus K to the other side. Okay, then probably the next instinctive step for you all to do will be to expand everything out. But I'm telling you that there's actually a much easier way. Okay, what you can do is actually divide both sides by Y. Okay, bring K over to get negative K, and then you realize that just by a simple factorizing of H out, you already have your big Y, big X, M, and C. So in this case, big Y is X, you realize big Y can actually also just be X alone. It is completely fine. Big X is X squared over Y, M is H, and C is negative K. Now there's an alternative solution to this. I'll leave you to go and figure it out on your own. Okay, take note of this. Okay, try and convert this equation into a y over x squared against y over x linear line. Okay, so I'll leave you to think about this. Okay, please make sure that as you are listening to this video, you are actually taking down notes on your exercise book or piece of foolscap. Okay, watching this video alone will not help you. Taking things down and actually writing it will help in your memory retention. Okay, so I'll see you in the next presentation where we will go through more applications of linear law.